constant of integration in both the sides. Okay, as we integrated once, there will be only one constant of integration. That constant of integration should be put either in the left side or in the right hand side, not to the both side. So, for example, let's say, let us actually discuss one example. Say, let us see this example. So here, actually, we will not able to solve all these questions, okay? Because after the separation of variable, we have to discuss again about the homogeneous differential equation, and again we will discuss with the linear differential equation one by one, okay? Because of why we will not able to solve all these three questions. Look, this question was given, and this question was actually only the NBS ROC practice paper, okay? And this question was recently asked in the 2024, okay? Here, actually, I would like to solve. Actually, I would like to give these questions as assignment. Okay, this question I would like to give as your assignment. In but instead this okay. Let me solve the another actually questions that can you understand more, and with the help of that you will solve these three questions. Okay, these are going to these are for your assignments question. Okay, so now let us consider one question. Solve 1 plus x squared dy plus 1 plus y squared dx equal to c equal to 0. So they are giving a differential equation of the order 1 and the degree 1. So it is asking to solve. Okay. So there's this. Here, listen me. So first, by the question itself, only the dx and the dy are separated. The step number 1 that I already get in the working rule is not necessary in this case. If the dx and the dy are not separated by the question, first of all, we from our side we have to separate them. But in this question, dy and the dx are only separated by the question itself. So step 1 that I mentioned in the working rule is not necessary in this case. And because of why we have to directly start from the second step. In the second step, what I suggested is if by using cross multiplication or cross division or exponential law as per suitable, okay, suitable that sometimes cross multiplication may be suitable, in other questions cross division may be suitable, in another question laws of exponential may be possible, okay, or transformation of the terms may be possible, and amongst the possible ways of actually separation of the variables, which is the suitable, okay, it is to be implemented. So here, if the right hand side is 0, dear students, if the right hand side is 0, cross multiplication can be done in the same side of the cross multiplication or cross division can be done to the amongst the terms which are in the same side. For example, in this case, right hand side is 0, and we have two terms in the left hand side. As the right hand side is 0, cross division or cross multiplication can be done amongst these two terms. Okay, parts of these two terms. Okay. So here it is said that this part is function of x. As per the rules of the separation of variable, function of x cannot be with the dy, and this is the function of y. This cannot be with the dx. Separation means those function of x should be with the dx and the function of y should be with the dy. So actually what we want is this function of y should be with the dy, and this function of x should be with the dx. In what way this should be? We can make this okay. That function of this function of y should be here with the dy, and this function of x here with the dx. And this can be done by two-way cross division. So this should be cross to this side, and then this will simultaneously bring to this side. Two-way cross division among these two terms can be done. So in this way, suppose first let us think that let us assume that this is already cross divided this side. Then what we have is one. Into this one cross by this okay. 1 by 1 plus y squared dy. Okay. So that now the function of y becomes with the dy. And now this function of x, as this is already transferred to this side, as it is already close to this side, what we have here now is 1. To this one, we can bring this in the denominator. So 1 by 1 plus x squared. So two-way cross multiplication done in separating the variable x and y in this case. Sometimes one-way separation method may also be required. Sometimes two-way. Okay. Sometimes transformation to the terms. Okay. By using the simplification technique that I mentioned in the step number 2, if the separation is possible, it means that your differential equation is able to find its solution. Now the separation is over. As the separation is over, now what you can do integration to that. Integration 1 by 1 plus y squared dy plus integration 1 by 1 plus x squared dx. And this right hand side integration of 0 is actually c, constant of integration can be put in the right hand side. Okay. And now you know that the integration of 1 by 1 plus x y squared. Just the basic integration may be required in finding the solution. In the last part, okay, in the last part and the last steps of the your usually procedure, the basic integration will be needed. For example, standard integration like 1 by x, integration of sin x, basic integration will be needed. Okay, here also integration of 1 by 1 plus x squared with respect to dx is what 10 inverse x. Then what about this 10 inverse y? And what about this 10 inverse x? If, for example, if both are 10 inverse, okay, whether you sense this arbitrarily constant in terms of the 10 inverse. C is arbitrarily constant. Arbitrarily constant means it is a constant, it can change with any other as per our desire. As per our desire. Okay. So this C, now in this side, what we have is 10 inverse all the time. So this better thing to make this equal to 10 inverse. So like this 10 inverse of, instead of this A, you can write 10 inverse of any constant, any arbitrary constant, say A. Okay. After this, what we can write is 10 inverse x plus 10 inverse y formula is here. So this 10 inverse x may be put in the first term, and this may be put in the second term. After that, you can apply the inverse differential function formula. 10 inverse x plus y divided by 1 minus xy, and the 10 inverse x. 10 inverse. After this, you can put this and this. This means it is not that you are to actually sometimes okay you are able to do up to this, okay, up to separate up to this. For this also some mark will be awarded. Okay, it is suppose by mistake you committed suppose sometimes you may commit the mistake in finding the integration. No problem. Use your community and your steps that I already mentioned should be followed so as to get at least some marks. Right? If you follow these steps that I suggested, surely you will get some mark. You are able to separate the variables. It means that you are knowing the you are knowing about the method of integration, that is separation of variable. So 0 mark cannot be given. So at least some mark will be given. Okay. There is system working in the mathematics. It is always it is not true that you when the solution is completely right at the time the full answer will be awarded. But if the solution is 50% correct, then it is also to be awarded 50% of the mark. So after this, okay. Say you can say that say x therefore x plus y is equal to cos in this 55 a of 1 minus x. Okay. So this is the way how the separation of variables can be done, and they can find the solution by this method. Once again, before ending the this method of solving, I repeat once again, this separation of variables method is not every time possible. It is possible in some cases where the variables x and y can be separated with the help of the cross division or cross multiplication or exponential, also exponents, and any others. If separation of x and y possible means if the function of x is equal to in the with the dx or the function of y is equal to with the dy, it means that separation is possible. If this type of activity is possible here, separation method is possible. Otherwise, separation method is not possible. So, so these are the actually few problems that you may try. Just say solve, say dy by dx equal to 1 plus x plus y of x y. This may be the problem that you may try. And this year, it is already there in the NBS ROC practice paper. And this solution is also already there. Okay. In that practice paper, you can see this type of the question. Here, most of exponential will be utilized, especially the variables. This is the question that last 2024. Okay, you can try this question. Then now let's go to the next. This is homogeneous differential equation. Say here is the that about the homogeneous differential equation. This may not be understood by you, but I will actually this slowly and how you can know a differential equation. You can solve by this method and generally and method of solving in what way the homogeneous differential equation can be solved. Okay, I will discuss. So the reason is here. There are two types of homogeneous differential equations. Two types of homogeneous differential equations are here. Homogeneous differential equation is nothing if the derivative is completely obtained. After the derivative is able to derivative derivative is able to put as a homogeneous function of 0 degree. And then we used to say that homogeneous differential equation. Okay. If we discuss this thoroughly, we take a lot of time. Okay, homogeneous differential equation, how to say homogeneous equation is not lot of time story is needed. But we have little time because of why I want to actually cover all the things. I don't like to cover all the things. Just I would like to start my experience with how you can know a given differential equation is homogeneous or not, and what method should be there in this case. So some and along with the solving, okay, this should be formality, but let me share my experience. Say homogeneous, the difference, homogeneous. Say to know whether a given dimension is homogeneous or not. Okay, we have to we have three techniques, two techniques, two techniques. This is for my experience. As per my experience, let me share how you can first uh, set set whether set whether the degree of all the terms in the difference define define only by excluding dx dy by dx. So I would like to explain this is a differential equation is given, and now you are checking whether it is homogeneous or not. In this regard, I am first suggesting that by excluding uh, dx, dy, or maybe the dy by dx, some terms are remaining here, and you should say whether the terms in the differential equation after excluding the dx or dy by dx are defined their degrees or not. We know there's a if any variable is under the under a function, that variable defines the degree. So, for example, say a sin x. In this case, the variable x does not define its degree because it is dependent on the sign. If your variable is dependent on something, the degree of that variable does not define. Okay. So what I actually suggested here is that check whether the degree of all the terms in the difference is defined or not. So sometimes previous students, if a term is given like this, x squared into y, a term is given variable square in the multiplication form. In such case, the degree of this term will be what? The degree of this term is measured by the sum of the powers of the variable. Here the degree is not 2, here the degree is not 1, here the degree will be what? 3. Here the power of the variable is 2 and the power of the variable y is 1. So 2 plus 1 will be the degree of this term. If the variables were in the product form, the degree of the term is measured by the sum of the powers of the variable. For example, say y squared into suppose x cubed. So it is a term. A term, you know, terms are distinguished by plus or minus, not by the multiplication and the division. So this is to be treated as only one term. For this term, what is the degree? Pi is the degree. Okay. So dear students, so first we need to say whether the degree of all the terms in the differential equation is defined or not. If any one of the terms does not define its degree, then your differential equation will be homogeneous. Okay. To be homogeneous, all the terms should define their degrees, and the degree of all the terms should be equal. Okay. So, if not defined, if not defined, if not defined, the degree of the degree of the any one of the term, that the differential equation is not the differential equation is not homogeneous. Is not homogeneous. Okay. On the other hand, if all the terms define their degree, so first term define their degree, second term define its degree, third term define its degree. At the time, you need to say whether are the degrees of the terms same or not. If all the terms are having same degree, it is sure that the differential equation is homogeneous. So, for example, say, let me give one example here. Let me give one example here. Say, as I suggested, is it visible? Is it visible? Okay, okay. Okay. See, the first example, it was actually in the 2024. Recently, it was in the CBSE. Set number is also mentioned here, 65 oblique 2 oblique 1. And then in this differential equation, actually, look, for the time being, let us actually, let me write here. Let me write that twice xy plus y squared minus twice x squared, so dy by dx equal to 0. This is the differential equation given. So here what I suggested is that how you can say whether the given differential equation is homogeneous or not. For this, first, for the time being, we need to exclude this derivative. Exclude this one. This derivative you exclude. If dx or dy were here, or dx were here, they are to be actually excluded for the time. By excluding this, okay, we have to check all the terms whether define their degree or not. So first of all, let us see this one. Here the variables are given in the multiplied form. So its degree should be measured by the sum of their powers. So power of the this, I mean degree of this term is 2. Degree defined. Here also degree of the term this term is 2. It is also defined. Here also degree of this term is 2 defined. Okay, it means that all the terms in this differential equation define their degrees as well as degree of the terms are equal. So in this way, we will able to identify that the given differential equation is homogeneous. Okay. So first, the important thing is that the correct identification. Once the correct identification is done, the method of solving is so much easy. Okay. So for example, you must able to identify correctly that this will be done by the separation of variable, or this will be done by the homogeneous, or this will be done by the linear differential equation. Actually, the students and students, when the question is in the CBSE paper, that you are actually getting nervous, and all are actually tension is started. This is what happen. Okay. Then you should be very patient, and try in your best level to identify the correct type of the differential equation, separation, or homogeneous, or and that linear differential equation. So, so now next is number two. Number two. Step number two. In the step number one, what I suggested is if all the terms in the differential equation are defined their degree and having the same degree, then the differential equation is sure to be homogeneous differential equation. Okay. And if one of the term does not define its degree, then the differential equation cannot be homogeneous. And number two, how to, pardon, how to, just how to, oh, degree defined or not. No. So once again, if your variable is independent, independent means it should not be under the control of any function. So for example, say suppose sine. Sine is a function. If the function sine control a variable, okay, maybe sine, maybe actually root, maybe log. If your variable is log means log. If your variable is locked by your function, at the time your variable doesn't define its meaning. So, actually, to define the degree, the depth should be independent, free. Okay. No, the depth should be depend on any other thing. It should be very clear. Okay. Hmm. And another actually next in the next suppose sometimes okay uh, uh, degree does not define, and if defined also not having the equal, degrees are not equal. In such case, another way to identify the homogeneous method is here. Say another method is very important. The second one is very important. important one. So let us discuss. If uh, the derivative, if the derivative, any problem in this, yeah, yeah, yeah. In this step two, actually, I only uh, those actually different degree of factors in this regard. I'm going to suppose this not happen. Say degrees defined and are not equal. It is not actually happen. Okay. If it is not happen, that means your differential equation will not be homogeneous. It is not like that. We have another way to identify the homogeneous differential equation. Say, suppose say when the completely actually defined, if the result of the derivative is equal to put in the form of y by x, in the as a function of y by x, if the y by x function is there, function of y by x is there. For example, say sine of say y by x is there. In this case, degree does not define, but function of y by x is there. If function of y by x is there in your differential equation, that will also be homogeneous differential equation. Or if the function of x by y is there, that will also be your homogeneous differential. Actually, I'm going to categorize uh, in the one by one. Okay, the first one is their function of x by y is not there. Function of y by x is not there. And in such case, degree of all the terms should be defined, and the degree of the terms should be same. This is if this thing is not happen, then another category we have. Okay, the another category is the thing, the derivative in the differential equation. If derivative is able to express derivative dy by dx is able to express as a function of y by x, in such case also the differential equation is homogeneous. And for this differential equation is homogeneous of the type one. Let me call this as type one. This is type one homogeneous differential equation. For this, in this differential equation, derivative dy by dx must able to express as a function of y by x. Okay, this is the second category. The first category was such category that in which all the time terms define their degree and the degrees of the terms are same. Okay, if that category is not suppose given, this type of the category may also be given, and then this is the first type homogeneous differential. The first was only the to identify. And the third, another term is also here. If the derivative is dx by dy, then it should be expressed as a function of say, x by y. X by y. This is the type. So for example, let me here. Let me show the example. See here. In this actually second case, in this second differential equation, function of y by no function is no particular expression function is not present in this case. In such case, for the time being, we have to actually exclude this dx and this dy, and I need to set the degrees of all the terms present here. This is degree 2. Here also will become degree 2. Here also will become degree 2. So this is the what? Homogeneous differential. Yes, the terms define their degree and then bring the same degree. And this is the first category one. And the second one, here look, a function of y by x is function of a. Function of y by x. If the function of y by x is present, here the derivative ever will be dy by dx. Okay, dy by dx. I repeat, if function of y by x is present in the differential equation, derivative ever to find the solution for the differential equation will be dy by dx. And the some other differential equation will also be homogeneous differential equation of the type 1, let me call type 1. Okay. And another one, let us see here. This problem number 6. See, in this, what happened? A function of x by y, e is function, a function of x by y is present here. If function of x by y is present, that type of the differential equation will also be homogeneous differential equation of the type 2. For such differential equation where the function of x by y is present, is for this available derivative x by dy. So this is about the homogeneous differential equation, identification of the homogeneous differential equation. This I would like to actually recap once about the homogeneous differential equation. The main problem is how to know that the given differential equation is to be is homogeneous or not. This is the main problem. So in this regard, I suggested you what you can actually do to know homogeneous or not. In this regard, I suggested 2 points. Number one, having the terms should define their degree and should have the same degree. If so, your differential equation will be homogeneous. Okay, if this not happen, if this is not there, then another type of the homogeneous differential equation is there. That type is that derivative should be either expressed as a function of y by x or as a function of x by y. In such case, your derivative, so your differential equation will be homogeneous. And for the actually differential equation in which the derivative involved as a function of y by x, the derivative number will be dy. And for those differential equations in which the derivative is given as a function of x by y, the derivative number will be dx by dy. Okay. So next is about the method of solving. Method of solving. Any queries? Any queries? Am I audible? Am I audible? Okay, okay. Can I continue? Okay. So now how to solve a homogeneous differential equation? Just we discussed how we can identify for a homogeneous differential equation. Identification can be done in 2 ways. Okay. So after this, okay, now after this you identify that your differential equation is homogeneous. Then how to solve it? This will be the next step. Okay. So suppose the differential equation is type 1. As I mentioned, for the type 1, your derivative never will be dy by dx. You find out dy by dx completely from the differential equation with the help of the, as I suggested before, with the help of the transformation of the terms and cross division or cross divide. Okay. Completely you do find dy by dx and the put in the form of is a function of y by x. Or sometimes okay, you can shorten this. I will explain my student condition. After this, okay, you put your differential equation in this form. After that, the method of solving is to put y equal to dx. You put y equal to dx. Okay. Then after that, solution separation of variables should be there in some step. After the separation, in previously separation variable was not possible. After this method, separation of variables will be possible, and the separation will be done. And then once I separated the variables, integration should be done, and the solution will come out. And I will once again for the different type 1 function of y by x will be there, and the derivative paper is dy by dx. For this method of solving is y equal to dx. Just you remember this. Okay. A lot of things to continue. We will do following by taking examples. Type 2, for the type 2, the derivative product is x by dy, and this derivative is the function of say y by x by y. For this method of solving is put x equal to dy. Okay. So after putting the x equal to dy, how this steps will go on, and will discuss it at another example. Okay. About the degree of the difficulties of the problem is dependent on the integration. So in this, actually, finding the solution of differential equation, actually basic integration will be required. Okay. So problem is difficult or easy, it is dependent on the easy or difficult of the your integration. So let us see by considering one example. The first question is so x squared twice equals 5. Say solve it. Twice x y. What was it? Twice x y twice squared. Then let me say find the particular solution of the differential equation. Say twice x y plus y squared minus twice x squared divided by dx equal to 0. When given that y equal to when x equal to 1. Okay. So this is CBSE question. So first, and then let us okay, whether the terms define their degree as well as terms are having its own degree by excluding the derivative. So let us I exclude this derivative and let's say the degree of this first term 2. It means that all the terms define their degree and the degrees are also set. So as further that the rule number one that I suggested, this will be a homogeneous differential equation. Just you are identified and to solve it, you have to bring in the you need to bring either in the type one or either in the type two. The, just to identify, I suggested okay, in this way you can identify. But to solve it, you are required to bring either in the type one or type two. So let us bring now if only things to know that this is homogeneous. But to find its solution, need to use the standard form, which is either type 1 or which is type 1 or type 2. Okay, as per your wishes. Say, first of all, I would like to transfer this, the as it is negative term, I would like to transfer this to this side. Twice x squared plus y squared. And then let me transfer this to this side. Twice x squared divided by dx. Nowadays, the students CPC used to ask, okay, they are giving internet options between the homogeneous and linear. Okay, homogeneous and linear. One of the two questions will be given. one from the homogeneous and the one from the one linear. And then their interval choices is there. Okay, not to answer for. Among the two, you have to answer one of them. Okay. So after this, okay, I would like to actually suggest you to find the dy by dx. So this is this twice xy plus y squared divided by x squared. So now your numerator is homogeneous of degree 2, denominator is homogeneous of degree 2. This is homogeneous. But you can declare that this is homogeneous. This is homogeneous. The difference is like this. Declaration can be done. Once you declare that this is homogeneous differential equation and you identify correctly, you will be awarded mark. Maybe as per the marking scheme, as per the value points mentioned here, you will get the mark. After this, is the derivative at present is dy by dx. It is the type 1 form. It is the type 1. Okay, type 1 differential equation. So the method of solving will be putting what? As it is the type 1, in what method should be here? Putting y equal to dx. You can name this as, you can put this in the box. Highlighted. Can be done. And then this method need to be differentiated. Derivative can be done to dy by dx. Derivative should be done dy by dx. Differentiation can be done with respect to x. In the right hand side, you can use other known you can use first function b derivative of the second function u derivative b plus b derivative of x. B derivative that method of derivative can be used. B first derivative of the x with respect to x is 1 plus second derivative of the first. The first means b derivative will be here. I repeat once again. First function means b. Derivative of the second function means derivative of the x with respect to x. That will be 1 plus second function x derivative of the first. And the first is derivative of b with respect to x. D by dx. So this is the thing. And now you are to do after this at this okay what you can do is these things can be substituted to the equation 1. After this okay you can go to equation 1 from 1. Okay. Instead of this dy by dx in the left hand side, you can put this. Instead, in place of this dy by dx, you can write this because here it is they are balancing. They are equal. So instead, this you write this v plus x dt by dx. Okay. So for the dy by dx, we write this. In the right hand side, let us see. Say 2x, okay, like 2x, and then instead of the y, you have to write dx. For this y, you write dx, but we have this square, so here, and here 2x. So once the substitution of the substitution done, they go different. Now variable will become separable. Separation will be possible. So let's see whether the separation is possible or not. B plus x dv by dx, and say what happened here is twice x squared b plus b squared x squared divided by twice x squared. Okay, and b plus x dv by dx. You take out x squared common from the numerator and that x is going to be the x squared. Then what will be in the denominator? What will be the result? Result twice b plus b squared divided by 2. I repeat once again. X squared can take common. He was
I see. Digging.
Yeah.
Sorry.
Sorry, there is disturbance. It may be by for the F. We already passed the 1 hour now. It's okay. Huh? Am I audible, yes, please? Is it visible? Yes, students. Hello? Am I audible?
Manovi. Manovi siapa?
Am I audible?
Yes, sir. Yes, sir. Yes, sir.
Okay, okay. So after this, dear students, look, I took out x square common from the numerator, and x square is coming with this x square. So this is actually this side only we talk about x. And then what we can do after this is this b can transfer to the b side, the function of b side, so that b and x can separate. So after this b is b, better to transfer to b side x d by dx, and the transfer this to the b side minus b. Okay, and then x dt by dx. Now you actually simplify this. LCM is 2 twice b plus d square minus this q should multiply here twice b, and this twice b is this twice b, and after this one you can use this 2 can cross multiply here. Okay, this 2 you cross multiply here twice x db, and then this dx can cross multiply to this b square dx, and what happens now? If we bring this d square to this side and this twice x to this side with the help of the two vectors, the separation will be there. So let us again transfer this function of b to the db side and the function of x to the d side, I mean separation. So what we have here is d square db, and this side what we have is 1 by twice x. Here 2 by b square, 2 by b square, and what we have 1 by x dx. Okay, so we've separated the variables. Once the variable separation is over, integration should be done on both sides. So therefore, integration should be taken on both sides. But here, as 2 is multiple constant, you can take out from the symbol of integration, say like this 2, multiple constant take out, and then 1 by b square is there. So this b square in the denominator can bring up b to the power minus 2. So that you can integrate this with the help of the power rule, that is x to the power n. In this side, 1 by x dx, and a constant of integration this side. Okay, and then 2 about the integration is by power x to the power n rule. So x to the power n minus 1 divided by n minus 1. Power integration x to the power n rule is used. Okay, and here inside what you can say log x plus 2. Okay, and then you have we have this is okay, minus 1 minus 2. Yeah, but the calculation is minus, and here is minus. This minus will multiply here minus 2 by b. Okay. And after that, minus 2 by substitution can be done. So the substitution can be done. Instead of the b, what we can write? So what y equal to bx. What we use in the method y equal to bx. From this you can deduct the value. So b will be what? Like y x. Okay. So instead of the b, you write yjx here equal to log of x plus c. Say after this, you can whatever this x and you write twice x by y equal to log of x plus C. So this is residence general solution of the differential equation. But question demanding us to find a particular solution. Actually, particular solution is such a solution to be obtained from the general solution by using the given condition. Okay, one condition is given here. Value of y is this, y is this like okay. Then condition should be utilized here, and then after the condition is whatever the value of c, and then value of c will be written here, and then will be the particular solution. So what was the condition? Now you can use this equation. Okay. So now here, what was the value of x? Let me see what. What was the condition? Y equal to when x equal to 1. Hanging or this. Huh? So cannot. Network is not. Network string is not good. Is it visible? So cannot. Then what the question is, y is 2 when x equals to 1. This is to be applied in the generation. Okay. Now in this case, what will happen? Let's see this equation number 2. Now to imply the value of y to be put here is 2 minus 2, and the value of x to be put here is 1, and the log of 1 plus c. So here is minus 1 after the expression, and the log 1 value, do you know, it is 0 plus c. So therefore, c equal to minus 1. So now, with the help of the condition, we are able to find that we found the value of c. This value of c will be written to the general solution, will be substituted to the general solution, and then the solution here will be the particular solution. Okay. So from 2, you again put the value of c in equation 1, which is the general solution here. Minus twice x by y equal to log of x for the c divided by minus 1. So this is your minus 1. Require particular solution. It is the particular solution. So this is the way of homogeneous differential equation can be solved. So as I already mentioned, how you can identify whether a differential equation is homogeneous or not. For this, I discussed two ways. One is checking of the actually degrees of the term, whether defined or not. Number two, whether the whether function of y by x is present or not. Function of x by y is present or not. If function of x by y is present, that is also homogeneous. If function of y by x is not present, that is also homogeneous. So there are two actually ways for actually checking the differential equation is homogeneous or not. Okay. So yes. So next is uh, oh, we have some minutes. Okay. So next is about the say linear differential equation. Okay. So here also, the main important thing is how to know that the given differential equation is linear differential equation or not. Okay. Once again, the main important things uh, is to identify correct method of differential equation. Amongst the we have three methods, separation, homogeneous, linear. Amongst these three, which one is the given one? We need correct identification. Okay. So in this regard, I wanted to say about the separation